do, re, mi, fa, sol, la, ti, do, re, mi, fa, sol, la, ti, do, and it keeps going forever. You really need 2 octaves like this to see what I'm going to point out. Your 2 half steps are mi and fa, 3 and 4, and ti and do, 7 and 1. Then the pattern repeats itself. But it's not at an equidistant spacing. 3 to 7, which we're going to measure from the lower of the 2, because if you measure from the upper to the lower, you get a different interval. And that is a good interval to study, but we will later. That's the famous tritone. But here we're measuring the lower note of each of the half steps ascending from 3 to 7 is 7 half steps. That's a perfect fifth. Brain does not like that. You're going to have to say it about 100 times in a row, or you will not remember it. Here's the thing. If you keep going and you want to measure the distance between those same 2 groups this way, still going up, from 7 to 3 is 5 half steps, a perfect fourth. It's not uniform. It's not the same depending on which one you're measuring from. If you're measuring from this pair of half steps to this one, it's a perfect fifth. If you're measuring from this pair of half steps to this one, it's a perfect fourth. Perfect fourth and a perfect fifth added together makes an octave. So you've got 3 to 3 is a whole octave. It would be the same 7 to 7. However you do it, that math is imperfect or not consistent to both of those intervals. It's always a perfect fifth from the 3 to 7, and the 7 to 3 perfect fourth. You just have to listen to that about 50 times, or you're just going to forget it immediately.